we should use such an item, such a value of epsilon. We have to specify it. And unfortunately, the value of epsilon, default one in the Matlab is very large. It is the 1,000. Epsilon equals to 1 to the power of minus 3. It is a very large value. It is equivalent to 0.1% of error. So it is too large for numerical computations. So normally we will select it at a very small number, and then we can have better control of the immediate result and finally the result of simulation. And now let me say how can we check whether the result is correct or not, and or how can we set the value of epsilon. OPT equals to ODE set. Remember that I have talked about the optim set, which is used for optimization. For ordinary differential equation, we have another template. And the template itself has many components. And the most important component here is the zero pole, which means relative tolerance. And this one is something similar to the epsilon here. And the default one here is 10 to the minus 3. It's too large. We can set it to a small number. So now let's solve the original problem again. Sorry, I have to set it first. OPT dot real TOL equals to 1 to the to 10 to the minus 6 order. So we can redefine the error tolerance. Now we can solve the problem again using similar method. We can write it as T1 and Y1. We can solve it again. We have decreased the error tolerance from 10 to the power of minus 3 to 10 to the power of minus 6. We decrease it by 1,000 times. But the calculation time required didn't increase much. Let's recall the previous result I get. This one is obtained by using the default error control. However, it is not correct. Let's draw the new one and the new error tolerance. So it seems that the original one is quite misleading. We cannot rely on too much on Matlab default result. And in other words, once you get the result, you have to find a way to validate it. And how can we make sure that this one is correct? We can further decrease the value of epsilon to 8. And this one also gave similar result to the previous one. So we say that the result is correct. And the time required for different selection of the value of the epsilon is not changing a lot. There are only a small difference between the number of points calculated. So there should be length T1, 2,000 points. It's about 2,000 points. However, this error tolerance is 0 to the minus 8 power, about 2,000 points. However, if you use the default one, it has 680 something points. So the number of points or computation effort didn't increase too much. So in this case, you can select a very small error tolerance to ensure the result is correct. So this is very important in calculation. Sometimes Matlab itself will give misleading results. We have to be very careful. So how can we solve this kind of equation? In this equation, we see that we have the highest order of x and y in the same equation. It is not the same as the previous one I used. So in this case, still we can select state variables like this, and then this one will be x2 dot. This one will be x4 dot, and the other terms are known. So we can solve the equation and finally find the x2 dot and the x4 dot. And the equation can finally be written like this. This 2 can be written out directly. However, this 2 has to be obtained by solving the equation. So we can transfer the original differential equation into this form, which is the standard form. Then we can use ODE 45 to solve it. And there are some certain differential equations like this, matrix differential equations, where x should be a vector. This is often seen in mechanical systems, Matlab equation. So for this kind of equation, how can we solve it? How can we transform it into this form? So what we need to do is to introduce x1 equals to capital X, because x itself is a vector, it's a column vector. And x2 equals to x, capital X dot. And we can join x1, x2 together, then we can form the final x vector. So we can finally transform the original differential equation in this form. It is again a standard form. We can solve it. And there are examples if you are interested in, you can have a deeper look at it and see whether it can give correct answers. And I have to remind you again that the very important step in differential equation solution is the validation of the results. Otherwise, you may obtain misleading results. There are actually many ways to validate results. To change the value of error tolerance is one way. The other way, you can change from one algorithm to another, because ODE 45 is one algorithm. However, in Matlab, several algorithms are provided. And if you type half ODE 45, then you can see that there are many methods that you can use. 2, 3, 1, 3, and other methods. You can choose different methods to solve the problem and see whether they give consistent results. So this is the introduction to these numerical solutions to differential equations. However, in my presentation, I left one